so let's talk about how we can write the equation of a rational function from looking at a graph. Okay, there's going to be 4 key features that we need to observe about this graph when it comes to then translating those features into the equation. The first feature we're going to look at are these 2 dotted green lines you see here. Those are your vertical asymptotes. Those are going to be a key feature we'll work with. Next up, this little spot right here, this open circle, it's called a hole. That's another key feature that is going to help us write the equation. Next up, anywhere the graph crosses the x-axis, another key feature that's going to help us write the equation. And then the final piece of the puzzle is this dotted horizontal line you see, the horizontal asymptote. So let's look at how those 4 features contribute to writing the function. So first off, we're just going to start out in general with f of x equals and then a nice division line here, okay? So remember, a rational function is 2 polynomials that get divided. So let's talk about what causes certain pieces to fall in certain places. So let's start with the vertical asymptotes. So you have a vertical asymptote here. This one, this x value that is causing that, is x equals -3. And this value causing the other vertical asymptote is x equals 5. So anytime that we are going to include one of these in the equation, any value that's of note, we're going to need to write that value as a factor. So writing this as a factor, this writes out as x plus 3, and this one writes out as x minus 5. So those 2 are going to get put in the denominator here because vertical asymptotes are created or caused when the denominator of a function equals 0. We can't divide by 0, so therefore we have a vertical asymptote occurring. Now there is one other thing that can occur in the denominator that causes our function to act up a little bit. And that's what we see right here, and it's this hole. But it's going to look a little bit different. So this hole is occurring at x equals 3. Okay? If we write that as a factor, that's x minus 3. Now the reason it becomes a hole instead of a vertical asymptote is because it has a partnering piece in the numerator that causes it to cancel out. So that cancellation is what creates a hole as opposed to a vertical asymptote. So I'm going to make a note here of where these things have come from so far. These 2 came from vertical asymptotes. These 2 factors came from our observation of there being a hole in the function. All right, so let's look at the next piece here. We said x-intercepts come next. So we have an x-intercept here at x equals -6. We have an x-intercept right here at x equals 2. Let's write each of those as a factor. X plus 6 as a factor, and x minus 2 as a factor. Okay, so x-intercepts occur anytime the function itself is equal to 0. So as though I didn't have an f of x here anymore, and instead I had plugged in a 0. All right, well, that means that what I'm looking for essentially is when the numerator of this function is equal to 0. That's going to cause those x-intercepts. So I can add those values in to the numerator, x plus 6 and x minus 2. So this is an x-intercept. That's what's adding it into this overall function. And this is an x-intercept. That's why I'm adding it in to the creation of my function here. All right, so the final piece of the puzzle here to get our last feature is this horizontal asymptote, okay? So this horizontal asymptote is occurring at y equals 3, okay? Now, if you remember, there's 3 different asymptote situations that can occur when it comes to horizontal asymptotes or slant asymptotes. So a horizontal asymptote is going to occur at y equals 0 right here if the power of the numerator is less than the power of the denominator. Well, that's not the case here, okay? We're going to have a horizontal asymptote occur at a non-zero value when the power of the numerator is equal to the power of the denominator. And notice here we've got x, x, x. Those powers are equal. We have 3 x's. So what that means, the way we're going to find that, is we're going to do that y equals 3 is coming from the fact that the numerator is going to have a 3 in it. Okay? So that 3 is going to produce the horizontal asymptote that you see right there. The third situation, which is another topic we can get into sometime, is the fact that you can sometimes have diagonal asymptotes or even other asymptotes, and that occurs when the power of the numerator is greater than the power of the denominator. All right, I hope you all found that helpful.